got a piece of paper, and we're going to have basically 3 kinds of problems on this quiz. Alrighty? So, the first, well, I don't know what order we're in, but one of the kinds of problems we're going to have on this quiz are the limit problems that we talked about yesterday. Or was that yesterday? Whenever that was, we talked about limits. So let me put a couple up here. These are just samples. All right, this should be enough practice. Here we go. And let's do 2n minus 3 over 4n plus 1. 6n squared minus 8 over 2n plus 5. 2 thirds, 17 plus 1. 5, 6 All right, here you go. This will be good practice. Okay? Can you answer any of those? I know it takes a minute to get them written down. Can you answer any of those? Think about it. As you're writing them down, maybe you're putting the answers right on them as you're writing them down. I don't know. Let's take a minute and see. You want to put that in your backpack, Ethan? Your phone?
Yeah, sorry.
That'd be good, yeah. Thank you. Well, I did, but it wasn't a math question. Has anybody thought about an answer to any of these? Olivia, give us one.
The top one,
Any number, 1, 2, 3, 4, 5, 6. So number 1?
yeah,
Yep.
since they both have the same amount of ends, it's
2/4, which we could actually reduce to 1/2. Yep. So everybody remember that little rule? 2n over 4n? 2/4, right?
Yeah.
1/2. All right, Maggie?
4 is 5.
4 is 5. That one we didn't talk about very much, but the limit of a constant. Is there any n in this at all? No. So when all you've got is a number, the limit of it is the number. So if it were an 11, it would be 11. Okay, anybody know any of the rest of them? Peeps, somebody's got to know something. What?
So for like number 2, since the n doesn't have an exponent on it, is that one of those problems where you put a 0
Yeah.
in front? So
Yeah.
then that would just be divergent.
Yes, because you would have to put the 0 in the bottom, and Maggie said, or Maddie says, hey, I can't have a 0 in the bottom, right? To make a match, I have to put a 0 down here. Nope, can't do it. Okay, good. What about this one then? Isn't this the same thing? Only the 0 goes on the top. And when that happens, the answer is 0. All right, what about these other 2? We talked about these guys. These are a different kind now. These are numbers to powers. What did we talk about when we have refers to powers. Maddie?
Oh, I know number 5 is 0, cause it's less than 1. Wait, no. It's divergent, cause it's more than 1.
Exactly. So this one's divergent because when you have a number, something, raised to a power, the limit is always gonna be either 0 or divergent. That's it. Those are the only two possible answers for a problem that looks like this. If the number that you're raising the power to is more than 1, it's divergent. If the number is less than 1,
0.
then the answer is 0. All right, so that is going to be a question or a few questions on our quiz. We did a whole page of that in the notes. If you are confused by this, maybe you should go back and redo those problems in the notes or practice these again. Okay? All right, so that's one thing on the quiz. Another thing on the quiz will be a situation where you have, let's say that you are reading a book, and on the first day you read, I'm not going to write out the whole problem, but on the first day you read 18 pages. And on the second day, you read 24 pages. And on the third day, you read 30 pages, and so on. The question will be, how many pages did you read on day 50? On the 50th day. Could you, well, first of all, do you see what's going on here?
Yeah.
What kind of sequence is that? You're adding 6, which makes it arithmetic.
Yes.
At the top of your quiz or somewhere on your quiz are going to be 2 formulas, the only 2 that we have so far. Today we're going to get some new ones, but this won't be on your quiz. These are our 2 formulas that we have so far. So you have determined that this sequence is going up by adding 6. That makes it arithmetic. Which of those formulas are you going to use in this problem? The first one. This is your arithmetic formula. Now, we want the 50th term. We want A sub 50. The 50th term. Well, according to the formula, A sub 50 will be A sub 1, which is what? What's A sub 1? 18, day 1. The sub tells you what day it is. A sub 1 is first day. So 18. You told me what the difference was. How did you say we were getting from term to term?
Adding 6.
Adding 6. And then, since I'm doing A sub 50, 49 goes in the parentheses. And then you can type that in on your calculator. 18 plus 6 times 49. And you're going to read 312 pages. All right, everybody okay with that? There were actually 2 of those problems on the field trip quiz that we did together in class. So if you want to get that back out, there were 2 of those, just like that. All right, one more question, and I bet you know what it's going to be like. Let's say, let's go back, let's do the same thing. First day, you read 4 pages. Second day, you read 12. Third day, you read 36. And so on. How many will I read? I promise I'll use better grammar on the quiz. But how many will I read on the 26th day? Well, it's basically the same problem, isn't it? What's different about it? This time, it's not an arithmetic sequence. This time, we're getting from term to term by multiplying by 3, which makes it geometric, which means this formula. So I want the 26th term. Remember, I'll give you the formulas, but you have to know this one goes with geometric. All right, so what's the 26th term going to be? According to the formula, what am I starting with here? A sub 1 is 4. You told me my ratio, my R, which is the number I multiply by, you told me that is 3. And if I'm looking for the 26th term, then what's my next term going to be? 25. Oh, this is going to be a huge number. Remember, you gotta count, you gotta include scientific notation, so this is times 10 to the 12th. You're gonna read a lot of pages on the 26th day. All right, so let's make sure we're clear on the expectation for our next class. We'll have to answer some limit questions, like we practiced. We'll have to do a problem with this formula, which is our arithmetic formula, and we'll have to do a problem with this formula, our geometric formula. Got it? Okay. Well, then we're gonna start section 9.5 today. Okay, so here we go. We do have office hours tomorrow, by the way. All right, here we go. Find the sum of the following series. Okay, now wait a second. Let's look at this first of all. Can you figure out what's going on? We're adding 5. So it's an arithmetic sequence, right? The difference is, before we were just looking for like another number in the list. This time they want me to add them up. So they want me to put plus signs in between and add them up. And there's no dot, dot, dot. Well, could I do this on my calculator? Could I take out my calculator and just start doing negative 18 plus negative 13? Could I add that up? Sure. What if there were 100 numbers in the list, though? That would take a long time, wouldn't it? So luckily for us, there is a formula for this. If it's an arithmetic, which you said this one is, if it's an arithmetic sum, adding them up, the formula looks like this. So write that down, and then we're going to make sure you know what all those letters stand for. The S is your clue that you're going, this is a sum formula. This will add. This formula adds, that's what the S means, sum, S-U-M. Now, N stands for the number of terms. So in my problem, 1, 2, 3, 4, 5, 6, 7, 8, I'm adding 8. So the sum of 8. Now, see this guy right here? He's another N. These N's match. In the same formula, the same letter always stands for the same thing. So, if that's an 8, that's an 8. From 8 over 2.
What does this equal?
4. 8 over 2. 4.
Can you write 4?
Yep, you can write 4. We've been using this one all along, guys. We've been using, what's A sub 1 stand for? The first term, which in our problem is negative 18. A sub 1 is always the first term. Oh my gosh, there's another N. Remember, N is N in this whole problem. So if N was 8 here and here, it's also 8 here. What does A sub 8 stand for? 8th term. And what's our 8th term? 17. So basically, this was the first term and this guy was the last term. He happened to be the 8th one, but that was the last one on my list. So it looks like our sum is going to be 4 times negative 1. I got negative 4 as the answer. If you sat and added all those up, you get negative 4. Okay, let's look at the next one. Same directions, we're going to add these up. Now honestly, there aren't very many numbers here. So one way that I could do this would be just to add those up. There's only 5 of them. I could do that real quick, add them up on my calculator. But if there were 50 of them, I don't want to do that. I want a formula. What you notice about this set of numbers, though, it's multiplying. You are not going to use this formula because what did we say this formula was? Arithmetic sum. Okay, so we're going to add another formula to your list. This is your geometric sum. It looks like this. If you are asked to add up arithmetic terms, you're going to use this formula. If you are asked to add up geometric terms, you're going to use this formula. These are R's. That's a 1. It's an N. Now, does anybody feel like you can set it up for me? For this sequence right here. S sub what? What does N stand for? How many do I have? 5. So S sub 5. All right, what's this?
The first term,
which is,
-2.
so -2 minus. Oh, another -2?
Yeah. To the, or,
What's my ratio? What's my R? What am I multiplying by?
to the 5th power,
3 to the 5th power, very good.
over 1 minus 3.
And 1 minus 3, perfect. Olivia,
How'd you get 3 to the 5th?
what am I multiplying by to get from term to term? 3, so R is 3. What did we already say N was? We already said N was 5. So we have 3 to the 5th. Now, these can be kind of hard to type in. If you type it exactly the way I wrote it, so including all the parentheses, you will get the right answer. Except, I would, before I typed it in, I would go ahead and say 1 minus 3 is -2. Because otherwise, you're gonna need parentheses around the bottom too, and kids always forget those. So I go ahead and figure out my denominator, and then -2 minus -2 times 3 to the 5th equals, and then divided by -2. I got -242. Did anybody else get that?
I did.
Good. As you do these problems, you'll come up with your own favorite way of typing it in. You do not have to do it exactly like I do, but make sure you're getting the same answer.
I got mine at 245. How is it that I'm like 3 off? She typed it in right, and I typed it in right. Maybe it's my calculator?
No.
Yeah. I was like,
It's operator error. I mean, I'm not, maybe I'm wrong. Maybe it should be
But she did
245.
plus instead of minus.
Oh, instead of minus. But I don't know why that would change by 3.
Maybe that's the only difference. I did minus 3.
Oh, I know what you did wrong. I know what you did wrong. Or she got by -2. So this is really important, guys. When you type this into your calculator, after you get your numerator typed in, you have to hit equals and then divide it by -2. Because the whole numerator has to get divided and not just the end part. So Maddie, all you did was divide the end part.
Okay.
You have to divide the whole thing. So I always type in the top, get equals, and then divide it by the bottom.
It's just so easy. 3 off instead.
Okay, because you didn't hit equals, that's what I just told her. You can't do the division until you hit equals. So let me say it again, and listen to what I'm saying. Tayshawn, what are you doing back there? Huh? What's in your hand? Okay, why is your phone in your hand? So, when you type this in, because the numerator is in 2 parts, unless you put it in parentheses, type in the numerator, get equals, and then divide it by -2. If you don't want to hit equals, then you must put the whole top in parentheses. Okay, so we're going to type in the numerator, get equals, divided by -2. Now, did you all get -242? Yeah. I know this stuff can be hard and tricky, guys, but you've got to fight through it. We can do it. When you're almost done with the course, you can do this. Okay, oh my, let's look at C. We're adding all this up. What's the first thing you gotta decide? Is it arithmetic or is it geometric, right? If you're adding, you know you're gonna use your add formulas. These are your sum formulas. But you don't know which one to use until you've decided if it's arithmetic or geometric. So look at the terms, what's happening?
Adding 4.
We're adding 4. If we're adding 4, we're using this formula. So S sub n equals n over 2, first plus last. Do we know the first term? We do. Do we know the last term? Remember, A sub n is the last term in the list. Do we know it? 53. We are so lucky. Whoops, our luck just ran out. What do we not know?
How many?
We don't know how many we have. So let's talk about options. What's an option we have? Could you just start filling in the dot, dot, dot? And then once you get it all filled in, eventually you'll get to 53. So you'll stop and then just count them up. Is that an option? Yeah. It's not horrible. If this were a 5,000, it would be horrible. It's doable. I wonder if there's a formula that might help us. This one's not working right now because I don't know what n is. I need to know what n is in order to do this. Here is my other arithmetic formula. Here's my other arithmetic formula. I know that the last term is 53. Remember, A sub n is last term. It's 53. I know the first term is 5. I know the common difference is 4. Can I solve that equation and figure out n?
Yeah.
I can. So let's do it. How do you want to solve that? I'm solving this equation. How do you want to do that? How do you want to do that? Okay, so one option is to distribute. Yeah, I don't care how we do it. I just don't know what makes sense to you guys. So right there I distributed. Now, girls, are you talking about math?
Yeah.
All right. Now I can combine my terms here. Subtract 1 and divide by 4. So how many terms are in the list? 13. Olivia?
How'd you get 4?
How do I get from term to term here, Olivia? D is the common difference. It's what you add to get from term to term. Once I know that n is 13, then I can plug that in here and I can find my answer. 13 divided by 2 times, parentheses, 5 plus 53. I got 377. Please type that in, make sure you can get the same thing. let's make sure we're clear on this. You did not need to use a formula. You could have added 4, added 4, added 4, added 4, and just kept adding 4 till you got to 53. And then counted up the numbers, and there would have been 13 of them. So that's an option. But what I want you to be aware of is your time isn't unlimited. So if there were 1,300 terms, you would not have enough time to do that. So it's good to have an option here with the formula, but you don't always have to use it if it's faster for you to do it by hand. So this right here, all this was the background work. That helped me get 13 as my sum, or as my number of terms. Then I could plug that in and get my sum. Did everybody get 377?
Yes.
All right. Let's see. Next. What's happening here? We're gonna add these up, but I don't know which formula to use because I don't know if I'm multiplying or adding something. Multiplying? What are we throwing around? What are we throwing?
It was just a starburst.
Okay, well, let's not throw candy. We don't need to throw candy. We need to just pay attention, please. Just pay attention.
It was just real fast.
I know. Summer's gonna go real fast too. Actually, it won't when you're sitting with me for hours. Let's pay attention so we can pass. That's our goal. All right. What am I doing here? I heard somebody say I'm multiplying by something. What am I multiplying by? I heard somebody say 0.2. 0.08 times 0.2 is not 0.4. 0.08 times 0.5 is not 0.4. Figure it out. If you don't know what you're multiplying by, you can't go anywhere with this problem. So we gotta figure that out. So here we go.
It's times a regular
Just 5. It's
Times a regular 5. So we are multiplying by a regular 5. Check your work. 0.08 times 5. And then 0.4 times 5. I think they're right. I think we're just multiplying by 5. Now, you could keep multiplying by 5 to see how many there were. Because the formula you're going to use requires you to know how many terms there are. You have to know n. This is geometric, so this is my geometric formula. I erased it, but I had it labeled here. Hopefully you wrote it down and labeled it. That's your geometric formula. I know the first term is 0.08, and you figured out the ratio was 5. So I know that much. I can fill in that many numbers. First term minus first term times ratio, oops, this is the one I don't know. And then 1 minus the ratio. What did we do in the last problem? All this here stuff. What did we do?
We used the original.
We used the original formula. So our original formula says this. That's what our original says. The last term is 1250. The first term is 0.08. The ratio is 5. When there's a piece of information that you don't have in one formula, go to the other formula, and it will give it to you. Okay, Kai? So, I didn't have my N, gotta have it. So I'm gonna go to my other formula, and I'm gonna figure out what my N is. So let's divide both sides by 0.08. So 1250 divided by 0.08 is 15,625, and that equals 5 to the n minus 1. Now listen to me. When this happens, this number over here will always be a perfect power, like a whole number power of that number. So this is 5 to the something. Has to be, okay? This number right here is 5 times 5 times 5 some number of times. So let's just trial and error. What's 5 raised to the 5th? Is it this number? 5 to the 5th? Is it that number? Yep, nope, it's not that number. I need a bigger number. So what's 5 to the 7th? Oh, that's too big. What's 5 to the 6th?
Oh, perfect.
Perfect. So this number is 5 to the 6th. This guy will always be a power of that. So if that's a 6, it'll be a power of 6. If that's an 8, that'll be a power of 8. It's a 5, so this is 5 to the something. And we just worked it out, and it's 5 to the 6th. So if 5 to the 6th equals 5 to the n minus 1, what does n have to be?
7.
Doesn't n have to be 7?
Subtract 1.
Yeah. 7 minus 1 would be 6. Or 6 plus 1 is 7, however you want to think about it. So n is 7. I can bring that over here and type that in. Now, again, I know we've only done one of these, but I told you I like to go ahead and make that a -4. I'll just go ahead and do that arithmetic before I get started. 0.08
Sorry.
minus 0.08 times 5 raised to the 7th equals divided by -4. That should be your answer. Hopefully it is. Type it in. Let's see if you can come up with that. Those last two problems were hard. There are some hard problems in this section, but there's also some very easy problems in this section. Everybody get 1,562.48? No? Did anybody get that? No?
Yeah, I got 5.
All right, let me try it again. Let me type it in again. 0.08 minus. Okay, well, I'm right, so we all should be getting this, so I don't know what you're typing in. 0.08 minus 0.08, parentheses, 5, parentheses, raised to the 7th, equals, divided by -4. Campbell, honey, can you type it in for me?
Oh, I already.
You did, and you got that? Okay, I wish you would have said I got that. Yeah. If who is still not getting it?
Well, I have a question.
Uh-huh.
About, it was like a previous problem, it's just like one thing I had to clear up with the, -4, the one that's up there right now, where it's like 53 plus
Yeah.
5 plus 4, where's the -4 from the and the very bottom?
It was part of the parentheses, I distributed.
Uh-huh.
The original had 4 n minus 1, so when I distribute, I got 4 n minus 4.
Okay.
The formula has that in it.
Okay, thank you.
All right, now we're gonna do a couple of easy ones. I hope they're easy. All right, here we go. Find the sum of the first 90 terms. So using my notation, this is going to be the sum of 90, so S sub 90. What's the first thing we have to decide? Arithmetic or geometric, right? Because we gotta know which formula to use. I do not want to add up 90 numbers. I want a formula. Okay, it's arithmetic. Would you agree? What's happening?
S plus 3.
Adding 3. So my arithmetic formula, I'll write it down up here, is this one. Now, again, I'll say it again. I'm going to give you all the formulas, but I'm not going to tell you which is which. So you need to know, okay, if it's an arithmetic sum, that's my formula, all right? N is 90, they told me right there on the page. So 90 over 2, N over 2. What's A sub 1?
3. Oh, it's a negative number.
Negative 2. Oh, crud. What do I need here? What goes in at the end of this? What's that? The last term. Shoot, I thought this was gonna be easy. Tatiana's putting her head down. When she puts her head down, we know we're in trouble. The 90th term, I don't have it. What did I tell you you could always do if there's a piece of information that you still need?
Use a different one.
Use the other formula. So the other arithmetic formula is this one. I want A sub 90. That's what I need right there. That's what I need in this formula. I know the first term is negative 2. What's my common difference? 3. And n minus 1 will be 89. That's pretty easy. So negative 2 plus 3 times 89 is 265. Is 265 the answer? No, what do I do with that 265?
Put it in
That
for the
goes
A.
right here, right? So I have 90 over 2 times negative 2 plus 265. Now you can type that in however it works for you. 90 divided by 2 is 45, so some people like to just say 45. Negative 2 plus 265 would be 263. That's fine. If you want to type all that in, that's fine too. It makes absolutely no difference. But we all need to come up with 11,835. So make sure that's the number that you're ending up with. 2.4, blah, 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 we're gonna add up 12 of them. What do you think?
Multiply by two.
Multiply by what?
2.
2? Does everybody agree? Looks like we're timesing by 2. Which means this is what kind of a sequence? Geometric. So my formula is a sub 1 minus a sub 1 r to the nth over 1 minus r. Again, I'll get that to you. But if it's geometric, then that's the one you're going to use. Oh, this one is easy, guys, because do I know my first term? What's my first term? 0.1. Do I know my ratio? You told me. How am I getting from term to term? Multiplying by 2. Do I know n? I sure do. N is 12 over 1 minus 2. Oh, I don't need anything else. I've got it. I've got everything.
Easy.
I'm going to go ahead and make this a negative 1 on the bottom. 1 minus 2. And I'm going to go ahead and type in my top. 0.1 minus 0.1 times 2 to the 12th equals, divided by negative 1, I got 409.5.
Yes.
Did you? That one was easy because we actually had everything we needed. We didn't have to go to another formula. All right? We'll do number 3 and then we'll be done for the day, okay? Tell me what's different, if anything, about problem number 3. 3A. Well, it's got fractions in it, all right.
Well, the denominator going up like 2.
Okay, so that kind of tells me what's happening here. Remember, we have to either add something or multiply by something. So what am I doing here? I don't think I'm adding by anything. I'm multiplying by a half. So, Kai, when you said the denominators were being times by 2, what we're doing is multiplying by a half. Because that multiplies the denominator but doesn't change the numerator. So if I'm timesing by half, it's geometric, right? But here's the difference. I don't know if you noticed there's a word in the directions. Well, sum, but I've summed these other things. Any S formula is a sum. What word is in there that I haven't seen before?
Infinite.
Infinite. What does infinite mean?
Never ending.
Never ending. Notice that if I'm doing this formula, or if I'm doing this formula, I have to know how many terms I'm adding up. And if it's infinite, you don't know that, right? So we need another formula. This is our last one. The formula for an infinite geometric sequence, or series, is the easiest one ever. It's that. That's the formula for an infinite geometric series. You will not have infinite arithmetics. If it's infinite, it's a geometric. Okay? Now notice, all I need to evaluate this, all I need to know is the first term, which is 3, and the common ratio, which you figured out was 1/2.
Yup.
So what is 1 minus 1/2? 1/2, 0.5, I might use 0.5 actually, it'll be easier to type in on my calculator. What is 3 divided by 1/2 or 3 divided by 0.5? 6. That's it. So the sum of these numbers, if you could keep adding forever and ever and ever and ever and ever, the sum of those numbers is 6. All right, 2 more and we'll be done. Here we go. Or letter B.
What? Not, because that's not even an order. 4, how does 4 to get to
Before I can do the problem, I need to figure out R. What's my R? What am I doing here? How am I getting along the line here?
dividing by -2?
Okay, dividing by -2, which is the same, it has to be a multiplication, so it's the same as multiplying by -1/2. Would everybody agree with that? So according to my new geometric infinite sum formula, the first term is 4. And 1 minus -1/2. Okay,
So you said infinite G will never be like subtracting anything, right?
right. You can't add an infinite arithmetic sequence. It's not summable, so I'm not gonna try to trick you. If it's infinite, if it's ... infinite, it's going to be geometric. Not all of these are summable either, but I'm only going to give you summable ones. I'm not going to trick you. What's 1 minus -1/2? Isn't that 1 plus 1/2? So it might make it easier on my calculator if I made that 1.5. Certainly your calculator can handle fractions, but you'll need parentheses, so it's easier just to do that. So 4 divided by 1.5. What'd you come up with?
2.6 is repeating.
Okay, would you hit your math button? Math frac? Did you get 8/3? That way we don't have to round it off. Hit your math button and then hit equals. And it changes it to a fraction. All right, one more. What's going on here? Multiplying by 2/3, Maggie says. Now, you guys, this one, I mean, it's kind of hard to see that. But if you look right here, it's a little easier. To get from 8 to 16, we times by 2. But to get from 3 to 9, we times by 3. So it looks like we are multiplying by 2/3. Remember, you do the same thing all the way down the line. So if you can't figure it out from the first 2 terms, that's okay. Move on down the line and see if you can figure it out. I think it's easier to see right here. So my formula says my first term is 6 over 1 minus 2/3. Right? What's 1 minus 2/3? Okay, forget the decimals. What's 1 minus 2/3? 1/3?
Yes.
So this is 6 divided by 1/3, which is 6 times 3, or 18. Now, if you did that on your calculator, assuming you've got parentheses going, you would end up with exactly the same answer. All right, that's it for the notes, but I have one more thing to show you that's just too cool. You don't need to write it down. I just want you to watch and listen because it's pretty amazing. Pretty amazing. This is a true story, so we're not on our phones. A little math history, and it's amazing. So let's go back a couple hundred years, maybe 300 years. And we're in a classroom, elementary school classroom, about 4th grade, 3rd, 4th grade, something like that. It's right before dismissal time, like Friday afternoon. All boys, this is over there in Europe, only boys went to school, it's all boys, little boys, 3rd, 4th grade. And they're kind of getting antsy, sort of like this. And the teacher says, okay guys, here's what I want you to do. Maddie, what are you doing? The teacher says, here's what I want you to do. I want you to add up all of the counting numbers, all the way up to 100. Now, these are 3rd or 4th graders, they can handle this. But even for you, this would take a long time, right? Because what you're doing is adding, you would add 1 and 2 makes 3, and 3 and 3 makes 6, and 6 and 4 makes 10. You could do that, but it would take a while. And that was the teacher's objective. He was just trying to keep them busy and focused just to get through the rest of the day. Well, the teacher gave this assignment, turned around, went back to his desk, and up came this little boy with the answer. And the teacher's like, wait, how did you do this? And the little boy said, well, you want me to add up 100 terms. And that's these terms right here, so I'll just put it up here. You want me to add up those 100 terms. But I know that I would get the same answer if I added them backwards. So 100 plus 99 plus 98, that would be 3, 2, 1, which is true, right? Absolutely true. Well, if I add these two together, then 2 of these sums would be, now look what happens, every pair you add. So the first and last give you 101. Look, what do these 2 give you? 101. What do these 2 give you? 101. 101. 101. 101. So basically, what I got here in these 2 sums is 100 101s, because there's 100 of these. Well, I don't want 2 of the sums, I only want 1 of them. So I'll divide by 2 and have 50 101s. And that's the answer to the question. Well, what that kid did, his name is Carl Friedrich Gauss, what he did, this is true story, you can look it up, Google it. What he did was basically use or create the formula that we used earlier. Because n is the number of terms. So he took 100 and divided it by 2. That's how we got the 50. And 101 was the sum of the first term plus the last term. And he did all that in 3rd grade without being taught any of it. He just figured it out. Pretty amazing, isn't it? GAUSS SS, that's his name.
Kenny, can I hear that?